Okay, so let's start. Today, I'm going to talk on the one of implicit non-functional requirement for any kind of system designs. Whenever you are designing any software systems, and by default, lots of customer business oriented requirement we have to implement so that customer can use, and at the same times we have to also, as a system design engineer, our responsibility is to provide some non-functional requirement NFR as well. So I'm going to talk today one of the uh, most, you can say, necessary NFR is the low latency. So today we are going to understand by default customer expectations are any software, maybe whatever the applications you are building. By default, assumptions of the customer is that our systems latency as possible as should be low. So you can say we are going to talk low latency non-functional requirement. It's not the customer tell us, hey, but it is our responsibility. We have to implement, develop, deliver our software that's have a low latency. So let's understand what are the way we can achieve this NFR low latency, non-functional requirements, and what are the tools, technologies we have available so that while designing systems, if we as a software engineer, we know that hey, these are the tools, these are the techniques, these are the technology already available for meeting this non-functional requirement like low latency, so we can easily integrate those systems technology. So what do you mean by, let's understand the what do you mean by low latency. So generally, whenever you are building any applications, okay, and applications you can deploy it on a particular region or particular locations. Okay, so if your applications are very specific for the particular region, that's another use case where you are developing software. That softwares are used by across the geolocation, means some person from the different location, some customer 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 from the different locations. If in this scenario, whatever the software you build, whatever the database applications, this is the only where you can deploy it. So in this scenario, if the customers which are accessing this application nearest to locations and one applications accessing the four uh, more distance than the another one is a further more distance. So the purpose of here low latency means that whatever the customers we have, customer can get or our application can serve from his nearest location, because whenever as far as our applications and our customers, they have a lots of remote data transformations required. Your data is travel on the internet, and that will take larger times. So objective of the low latency not functional requirement is that if possible, this customer can get the same data from the nearest data center or nearest web application, this from the nearest, this from the nearest, and this from the nearest. So the objective of here uh, low latency means our application somehow in this way deployed that whatever the region the customer is, the customer is able to access from the nearest location, so that our system or our customer get uh, quick response, you can say. So here, low latency means our applications and our customers, what the delay time between the customers and between the application server or your system. Those delays between the customer saying, hey, I want this data, and how much time our application take to response, right? So those scenario, lots of techniques I will going to talk where we can achieve this low latency. Let's understand low latency means that if how much delay between the customer send hey I this net, how much time data take to response back here. Simple. So if this delay as low as possible, low latency means simple. How much delay customer we have to wait to get response from the server. Okay, so let's talk about the here. Notice whenever you are deploy your applications, so lots of different kind of latency means where our user requests take some time to serve, right? So good example, whatever the your users are accessing the application, and from here the user requested hey I want data. So from user machines, from laptop, from mobile, how much times required to request go to the server. So there are some millisecond microsecond time required, so request reach to the our application server data center, and might be to reading data, processing data as per the customer requirement, it will take some time. Okay, that's our data center, our application server also takes some times. And after that, again, once our applications have prepared the response, they are going to again send on the networks. Again, network takes some time to receive the data. Might be here some where the application side, some firewall, some conversion, deconversion, those times also need take. So latency means if this customer has submit the request, and after how much time it will get the response. So these the time gap or time interval known as a latency, and our objective low latency, this delay time as small as possible. So here notice simple network latency means how much times your request travel on the networks and how much times your response travels on network. This is known as network latency. So latency cover your network latency plus your request response lessons, your application processing time plus response build times, and again network time. Similarly here again front end application UI application also takes some times. All the times you can sum and then hey this is the our application latency, yeah, network latency, yeah, overall customer perspective, these are the latency at time delay. So from the definition perspective, low latency refer a short delay as possible as minimum. The time between the data sent and the time it is received are processed. Everything. Okay. So this is the users and they want to, hey, I want to some data. So how much times it will take on the networks, our application receive, do some validation, so do some authentication authorization, day processing, call the database, get the response, again do processing, and again response back to the user. So how much times, complete times you can say from the user send time and what the receive time. So they can consider your network times, application server time, again network times to get data from the database or third microservices, plus your response build times, again your network times. So complete times. So if all the times considered as a, we can as short as possible. So in other words, low latency means just a time take for a signal or data to travel from one point to another point. This is from the application user to the data server to the user. So you can say these generally whenever you can define designing any applications, by default the customer expectation is that our latency as low as possible. So these are the very you can say critical NFR, and we have to think while system designing how we can meet these low latency non-functional requirements. Let's talk about the if uh, what the kind of desirable low latency are meaning, or you can say the situation where it's very required. So in general, low latency is very desirable of any kind of application. Overall objective is that whatever the communication happen, that as much as fast its data is transmitted and received quickly, enable the rapid communication and interactions. Whatever the uh, uh, channel mechanism communication between our applications and our machines, whatever the your one human users can interact to the machine or software as possible as quick communication happen. This is not only from the human user, maybe another application, maybe one application, one microservice talk to another microservice. So as this is also kind of a latency. So we have to minimize those communication times and as possible as real-time response. The objective of the low latency that our applications is so quickly response. Look like, hey, I am say hello, you can quickly respond. Just like in the real time is I am and you are in the same room, I am talking, hello, how are you? Quickly you reply. There is a no latency. There is a very minor fractions of latency. So our objectives of the our system design is that our applications response time would be as real as possible. So here real time response low latency if for our systems we are referring at designing, our objective is that our response is as real as possible. System can respond quickly to user input, making application feel more responsive and interactive. So as our application, my application is responsive, that means they are quickly responsive. And that is the also one of the key benefit if you are designing system in the point of view that the low latency should be maintained, that means we have to improve the performance. So latency, if latency is very low, that means you can say my application performance is as expected. And as quick, as fast, as more efficient, our applications should be responsive to the customer, to the user, to the machines, to the another applications. Okay, so let's how to measure this timing. Okay, lots of factors, lots of pointers to know how let's you build application, and once your application is ready, then as a our engineer teams, our testing team, we have to somehow measure whatever we committed to the customer, our application is responding on those cases or not. So multiple you can say technique we have applied. Make and you can just better way, just ping from your to your application and our particular port application running and measure the round trip time for the packet to travel from a device to the server and back. Means just from your client machine, just ping them, network packet go here and our application response them. Okay, the complete times, your sending times, network time plus your processing time plus your response time, all add and that become your ping time. Sometimes a round trip time. Round trip time measure it's a time to take a packet from the travel to device to the server back. right? So you can say using the ping command or RTT you can measure, or sometimes you can measure the 1 minute delay, measure time it take a packet from travel from device to the server, but not to the response. So maybe sometime I want to measure first how much times our system just take time to receive the user request, because some user your nearest location, some users are further location, some user the different geographical location. So in those scenario might be your application is very performant, but still your low latency is not as good as needed. So low latency not consider just your application should be quickly responsive, complete from user perspective, from the device from where user send request and how they receive it. So you have to consider the network, the communication channel, which kind of protocols we are using to communicating client to the server. And sometimes we also perform our latency testing, and we have lots of tool available, specialized tool available to check your latency. Such tool good option you can ping plotter or trace route or wax sock, lots of tools available to test the latency of your application. And you can also analyze, test your, apply the some testing tool as well as continuous base. We have to analyze our latency, we have to calculate the data, and time to time to measure our latency is going to increase or decrease, increase or decrease, increase or decrease. So if we have a somehow plot the chart and diagram the continuous basis every minute, every 10 minutes, and then we figure out which times, which time frame our application latency is high or our application latency is low. So if our application latency is low and maintain the constant, that means we are measuring the right. So analysis latency tools is very clear cut, give the idea about my application's latency. So let's talk some technique which help us to meet this low latency requirement, application performance you can say. So further, first always we have to think whatever you have build your applications. So first your application as receive the request and they are doing some input validation, processing, some rule apply, some filter apply, call to the maybe database call, validate some user, then call to the third microservices, and this microservices again response, then prepare the build and finally response. So these are the applications. So first this application whenever I call, how much times your application take to get the request and response. If first time I got do all the processing again, second time again doing, third time again doing, fourth time doing, is it possible not for the, if same request again come, why we can again processing, validating, calculating, and going to database call, going to the microservice call, prepare the request, and then the response. So somehow we have applied some caching technique. Caching technique saying if same request come again and again with a high frequency, so don't go call multiple time database, multiple time microservices. Why not you cache the result, store the result and response quickly until the data not change, until the microservice response not change. So that's mechanism known as a caching. So first and very important to meet your low latency, you have to integrate the cache in your system. So caching means storing frequently accessed data in the cache and reduce its time to take retrieval from the original source. So instead of calling database, instead of calling microservices, preparing response, just first time prepare response and store on the local nearest location in the cache, and so that next time you respond quickly. And one of the also very whenever your applications deploy into the across the geographical locations, you can also use the content delivery network CDN. That's distribute the content across the multiple server and reduce is the distance that need to travel. So CDN what help us if your applications are deployed at different geographical location and all the users are trying to access, they have every request come on your center. So why not across the geographical location, different location, different nearest locations? Why not we have a make a duplicate copy of my contents so that customer can get the nearest content. So we are can also use the CDN to reduce the travel time between the users and the your server. Even nowadays, we can use the edge computing concept. Instead of going to the complete your cloud centralized cloud data center, why not you can edge? The means which network, devices, sensor, the nearest location should be processing the same edge device. Why not we cache them data, closure the data? So edge computing nowadays also provide the processing data closer to the sources and reduce the latency by minimizing distance need to travel. Might be example, it's here your one IoT device sensor. They are generating lots of data. So you are sending all the data here, all the data here, all the data here, and you receive all the data and then sum them, aggregate them, summarize them, and the summarized data might be required the same device here. Again, you are sending the same data here. So unnecessary, you are transferring all the data, summarize them, and again response sending to the here. So why not this again all processing doing inside the device and nearest location? So that just summarize the data and whatever the outcome so here and finally one give the response to the hey these are the finalized within the 1 minute these are the calculated data summarized data, right? So different way where you can reduce your latency. Just think where, in which scenario, in which flow, my data is travels, your request travel longs and longs. So our objective, we have to reduce them, we have to lower them. And even we have to think our routing up if we are using the load balancer, API gateway, lots of routing algorithms, routing tables available. So we have to optimize our routing table as minimum number of hop our system. Maybe our server here at these times maybe our request goes to hop number one, hop number two, and then request receive here. So multiples due to the networking concept, multiple hop, multiple through channel our application receive. So we have to also trace complete your user request and the system request the number of routing. So direct routing possible, how much minimize those indirect routing possible. So we have to find out the most efficient path that travel data from the client to the our application. So lots of techniques we have, you can say, and even one you have to think. This is your application. This is your user want to access application. This is my application. So one things you can also here latency is not just only on the application side. Application side also means ki whatever the code you're writing, optimize your code first, optimize your code, minimize unnecessary computation, unnecessary. You can use if effective algorithm, whatever the database query, whatever the database query you are written, try to write the optimized query, use the cache query, use the procedure functions, and where possible you can apply the indexes. Lots of you can say mechanisms, yeah, technique we have available at the application side. Means your whatever the code you are writing, which language you are writing, the use the effective code, efficient code. Similarly, whatever the database query you are using, optimize your query. And similarly, if your application receive the lots of requests on a particular one server, you can use the load balance. So lots of technique we have available for achieving the low latency. So you can optimize your TV, optimize your code, multi-threading, efficient algorithm, best database, caching, CDN, lots of these techniques. If we think while designing our system, by default, whatever the system you're delivering, that will meet the low latency requirement. Okay, even you can think the network side of it, what the networks you are using, what the network path, what the routing path, which route our user requests from the a geographical location to come over the geographical location. So we have to optimize our network infrastructure as well as, and maybe upgrade your network hardware, optimize routing, optimize quality of services policies. So we have to think, we have to also talk our network team, infrastructure teams, hey, why such a packet take a time to travel from the user to the my server, and from server to the user. Even you can optimize up, you can use some compressions and encryption technology. Miski, hey, I have a big kind of data size. Why not I some compress this, minimize them, zip them, decode them, and again traverse somehow. So we have to lots of not compression techniques which reduce your data size. And when your data size is reduced, whenever you transfer those data on the network, your network uh, consumption also required less bandwidth and easily reach your data. Fast communication happen. We have to also ensure that secure channels, encryption, decryption technology can use to while sending and receiving data. So you can say lots of techniques we have available. We have to plan them, and sure we have to monitor and analyze our application latency, our database call latency, third party microservice call latency, your customer and between your application and customer, your network latency. So every places you have to think from the user, maybe your front end application, what kind of optimization required, what the CDN required, client side, you can say caching, load balancing, client server side caching, load balancing, API gateway, lots of things. So we have to think different latency means we have to think every aspect from front end application, from network perspective, from your database, maybe your centralized database, different database. So lots of times take to process to fetch data. Maybe you are calling some third party microservices, and then maybe third organization services, you are accessing something to respond the data. In those all scenario, you have to consider all the time, because the low latency, consider each and every times your user take to process. You cannot say, hey, my API very fast responsive, but users get the slow response. Why? Maybe network problem, congestion problem, uh, quality, your bandwidth, network bandwidth problem. You are using the 2G network, 3G network, 5G network, edge computing, lots of things. So you have to think where is the, because low latency is the term for the customer. How fast my application responsive for the customer. Customer don't know which network channel you are using 5G or using 3G or 4G, what network bandwidth consumes. We have to take care of everything. So monitoring and analyzing latency is help to deliver low latency software or system to the customer. Okay, so in general you have to define our threshold. Hey, generally, what do you mean by low latency? This is the depend upon the, you can say, it's keep in mind this acceptable that low latency threshold vary depend upon the specific application and use case. Depend upon the use case, depend upon the context, depend upon the situation. Low latency can be vary, but in general, lots of low latency means your application should be responsive within a 5 second, 6 second, 7 second, 10 second, 20 second. This is the millisecond that we are talking. And a medium latency means your application is responsive more than 50 millisecond. that means you have not meet the low latency requirement. Your application taking more than 200 millisecond or second, that means your application is come under the high latency. This is the different this is not any fast rule, you can say, because the nature of business, nature of data is going to process, the environment, customer load, lots of factors matter to measure the low latency. But you have to talk to the customer. We have to show our latency to customer. Hey, in this my environment, this is my dev environment, staging environment, QA environment, the number of load, the number of user, number of concurrent. Look, calculating latency is not just you can test one single user and the response again bad. What happened? Number of user going to the increase. Hey, 1,000 user concurrently, 10,000 user concurrently. Then what our system responsible? What happened? 1 million requests come per second in my systems. Then what level of latency? So latency required large of load testing, integration testing, and lots of latency testing tool we have to use. We have to check if my applications are going to the higher number of concurrent user. The same time, millions requests come on my system, then how my system responds, what times. So this is the threshold first defined by your QA, your test environment, and test environment also lots of load, minimum load, average load, and maximum load. You have to categorize if our system have a load can be different here. Consider whenever you are going to test. So here our applications have a lots of data. So what the data size we have, what the number of concurrent requests coming. So you can consider the huge million of concurrent requests, large data volume already we have in the system, and in those scenario, what how much latency we have to talk, what the latency, what the response time for the customer, for the API response, for the relay response. Okay, so lots of factors you can say consider while calculating a threshold for the low latency. Not you can say, hey, just simple database, only limited data set, and 1 or 2 to 10 requests you send and say, hey, this is my low latency. In the real, whenever your application deployed and go to the production and customers say this application is where the millions of users they are going to use, at that time say, hey, our application have lots of problem. So we have to maybe run the lots of pilot testing, demo, and ask customer feedback. Customer asks, hey, this is my product, staging environment, testing environment. Maybe you can give some limited feature to the customer. Okay, here also lots of limited feature with you are uh, releasing this threshold with a what number of feature, 2 feature, 3 feature, 10 feature, because depend upon the features, depend upon the nature of the business. So these are the very subjective threshold, but in general, low latency nowadays, whatever the social media, whatever the you are using, what are the your e-commerce platform you are using, what are the trading system now we are using, like our stock market and all the financial transactions you are doing. So they have very required low latency. So in those scenario, we have to take whatever the we designing our application that also meet the latency. This is only possible to monitoring, analyzing, and setting your threshold from the lots of test environment. Okay, so lots of places where the low latency is very required. If not low latency, customer feel not good for your application. Maybe you can talk if you are doing video calling nowadays. all the video calling, conferencing, meeting, lots of going on, lots of private agency, government agency, governments are doing the video conferencing for the policy, for discussion, communicating. And while video conferencing or online streaming, any live event happen going on, at that time your application low latency is very very essential, so that a real time video and audio communication happen. If your application latency is very very not low, that the delay between the audio, video, and the interest of the customer we can lose. Similarly, you are playing online game. While playing game, your application is not too slow responsive. Your application as fast as responsive while playing game. Game users are not feel uncomfortable. So fast response time is very very critical for all the gaming experience or all the online gamings are nowadays we are doing. Similarly, like your financial trading, whatever the financial trading happen, low latency is a very, very crucial and fast and reliable trade execution. There are delay in the result and significant financial loss happen. Okay, so these kind of, if you are in financial also trading also very very, you are building some trading platform, some application exchanging data. So here the low latency is very very critical. Nowadays, maybe you are using the virtual reality VR or AR tools, gaming, and lots of showcases were going on. Here also vector, because lots of in the virtual reality we are using the lots of tool, lots of images, lots of photograph, and interaction look like very real, and that is reality very real only possible if your application have a very very low latency, and that seamless and very very customer experience is very very high if your application maintain the low latency, because the very smooth image transformation happen. A real image look like a real, not the our machine driven systems we generated. So in this scenario also, your whatever the system you are designing, that must maintain the low level of your latency. And nowadays lots of application using the cloud computing. And now cloud computing, if not so responsive, so quick response, this is very very you can say business loss for any cloud computing. So cloud computing also offer the low latency, is very very important for any cloud based application where data is stored, processed, returned. So objective is as quickly as response. So whatever the cloud computing, they also all the services they are offering as low latency. So you can say lots of industries, lots of example where you think whatever the nowadays our IT industries are softwares are used by the, or you can say healthcare domain, financial domain, gaming domain, your healthcare domains, your security domains. You can say many many places, space domain, where the lots of calculation going on. So all this scenario you can say response of the system as low latency required. So please be think, if you are delivering customer, and these are the NFR, not the functional requirement, this is the non-functional requirement. Our responsibility, we have to make sure that our data is delivered as fast. So good example for the video call, on conferencing call, anywhere you are doing. Okay, so lots of timing we have to consider, not only so when any video recording, a video conferencing going on, so lots of here encoder, so broadcast encoder, you can say hardware, software, lots of encoding channel required. And then your networks, how much networks have networks internet to go the different. Again on the client side we have applied some decoder, again software decoder, boxes decoder, decoded hardware, which platforms, mobile, tab, laptop, on which uh, uh, devices you are watching this video or streaming or conferences. Accordingly, our tools, lots of software tools we are using the decode, so those kind of a times also take. And while networks also, what kind of a hop, what kind of a route, which route your system fall, the packet loss, jitter, intermediate networks or firewall, lots of firewall we have to travel from the this organization to this organization. So notice lots of places your request travels, and each and every times we have to optimize, we have to consider, we have to plan, we have to measure, we have to analyze, and then we can say, hey, my applications are where we required optimizing policy, better deployment. We have to think. Until you don't know where is the my latency going high, where my latency going consume majorly, then how we can work on that. So first we have to plot out all the route from where our user request goes, and then you can travel, right? So lots of you can say reference contents available for us, and we have to look them, we have to plan them. So let's look this kind of this is the very you can say I have already all the contents whatever we have, just we have to choose here the like a brief summary about the high concurrency and low latency system designs. Lots of uh, 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 our networks level, they mention, hey, what about the networks level latency, how to calculate, how is possible. And while the network level latency, we have to figure out the number of hop, network conjunction, distance between the client and server, choice of load balancer, maybe faulty network card, misconfiguration of your Ethernet card. So lots of pointer we have to think that might be cause delay or response in your latency, right? So maybe a number of hops you can decide. Lots of number of hop changes happen. Similarly, you can talk about the network congestion. Okay, so notice whenever you are going to use any internet, and that is a very nice lots of we if you talk as a we as an engineer, we have to know if the particular customer, a customer from here, they want to access data from this b, how our data exchange happen. There is no any magics happen between your mobile to the server. If from my mobile or device any transaction, any request I am requesting, lots of concept, technology, tools behind that help us. So in the case of internet working, whole worlds, the internet cables are placed. Maybe some distance, lower distance, we have used the Wi-Fi, but longer distance Wi-Fi cannot work. So lots of underground, undersea, all kind of cablings of the internet is already placed, and any data travel that required some kind of a timing, microsecond, nanosecond, millisecond required. So if a customer from this location, so notice the which route, which hop, from how, which route they follow to reach here. Okay, so notice lots of this kind of cabling, wiring, optical fiber cables are placed under the sea, under the earth. Due to that, nowadays our all the earth we can consider as a communication happen between the across the location, across the geographical location, feasible, because already our internet networkings are placed, are available. Due to that, we have to consider my applications and where is my user, what kind of network latency, what kind of network time take to travel. So low latency, majorly, one is the application. You have to write the very highly efficient algorithm, effective code, effective query. That's okay, but you have to also optimize your network congestion, network route, which route follow, which kind of algorithm, which kind of load balancer they place here, right? So lots of techniques we have available. Just go and check out. Okay. Similarly, we talk about the AWS also define well how we can meet the latency. What the latency meaning? Okay, same delay and network latency. You can talk the latency importance. They talks everything here mentioned. And for this, how we can meet the low latency. AWS already have a lots of product available which help us to lots of kind of cheater compression, which we talk everything they mentioned, and you can just go and lots of they have a inbuilt tools available. You can use those tools, right? So let's just check out. We as understand lots of tools and technique available for us, but our responsibility, at least we should aware how we can meet low latency, because whatever the system we are designing, this is our software engineering responsibility to ensure that customer are machines which are communicated to my server, my application, my system. This is the my system. Okay, whatever the maybe any mobile user, desktop user, whatever they are communicating, some system, some other third-party application they are communicating. Each and every users get response as quick as possible. Okay, so we have to ensure that. So first things, whatever the software you're building, our software is very performant. Means you optimize code, your effective algorithm, effective database query, lots of load balancing, API gateway, all the things we have to place here so that our application API is very fast, very responsive. But after that, we have to also consider the network level latency, where from which locations customer are going to serving. So for that, we have to apply caching, server-side caching, client-side caching, UI applications, CDN, load balancer, everything we have to place to meet the load balance, uh, to meet the low latency. Okay, so this way, if we as a software engineer, our responsibility, at least we should aware that whatever the system we are building, what the point network level, route level, front end level, back end level, networks level, channel level, application server level, router level, gateway level, caching level, CDN level, all these tools available which help us to design the system that meet the low latency requirements. Okay, this is for the today. Thank you.